Hello, you are welcome to today's class. How are you doing? I hope you've been doing very great. My name is Miss Adana Obu, and in this class, we'll be looking at a topic in chemistry for SS1. So far, so good. We've treated topics for week 1 to week 7. So in this particular class, we'll be looking at week 8 topic. So let's look at that. I hope you've copied the notes of the ones we've treated before for week 1 to week 7, and you've been doing the assignments that are there. Please always endeavor to do that. Now, let's look at the topic. The topic for today is carbon and its compound, which we started last week. And then today we are specifically looking at oxide of carbon. Now, when we talked about oxide of carbon, compounds of carbon in the last class, we actually looked at carbon itself and the different allotropic form of carbon. So we talked about that. Please try as much as possible to go back to the video and play them 2 or 3 times so that you can get a better understanding of it. So let's look at today's learning objective, our learning objective in today's class. Number 1, should be able to state the oxide of carbon, explain the preparation and properties of the oxide of carbon, state the uses of oxide of carbon, and describe the test for the oxide of carbon. These are the things we hope to achieve at the end of this class. Now, I need to mention here that when we say oxide, it means like oxide of carbon, we are saying carbon and oxygen in a chemical bond. So that is known as oxide of carbon. There are actually 2 main oxide of carbon, 2 oxide of carbon. There are 2 oxide of carbon, which are carbon 4 oxide, which we know as carbon dioxide. That's the common name. Carbon dioxide, carbon 4 oxide. While the other one is carbon 2 oxide, which is also known as carbon monoxide. That's what it is commonly called. But carbon 4 oxide and carbon 2 oxide are the IUPAC name of those compounds. Now, this oxide, they are formed when carbon or any form of carbon-containing substance born in air, that is oxygen. Oxygen is the active part of air. So when these substances born in air or oxygen, they form oxide. Now, in plenty supply of air, that is plentiful supply of air or excess air, excess oxygen or excess air, carbon 4 oxide will be formed. While in limited supply of air, carbon 2 oxide will be formed. Look at the reaction, you see the reaction and you see the product. So carbon 4 oxide is CO2, while carbon monoxide is CO, and they are both gases. So those are the products of the combustion, burning of carbon materials or carbon, any substance that contains carbon materials. Now, the next thing we look at is carbon 4 oxide, CO2. Now, the atmosphere is made up of 0.05% of carbon 4 oxide. Now, we know that carbon 4 oxide is one of the byproduct, major byproduct of respiration when we breathe in and breathe out. The air that is passed out of the body is actually carbon 4 oxide. And that carbon 4 oxide is used by plants during the process of photosynthesis. Now, when carbon-containing material are born in excess oxygen, it will use carbon 4 oxide, like we said before. Now, look at carbon-containing substances like you have C3H8. This is propane. Bonds in oxygen to give you carbon 4 oxide and water. And then this is glucose, C6H12O6, bonds in oxygen to give you carbon 4 oxide. These are a product of the combustion of carbon-based materials, or like we said in the former one, you see, this is carbon substance. It could be in form of diamond, graphite, or coke, or even charcoal. These are different forms, or even lamp black, that's soot. These forms of carbon, they burn in oxygen to give us carbon, sufficient amount of oxygen to give us carbon 4 oxide. And any material that contain carbon, we burn in oxygen to give us carbon 4 oxide in plentiful supply. That is when oxygen is in plentiful supply. So now let's look at the laboratory preparation of carbon 4 oxide. In preparing carbon 4 oxide in the laboratory, we react marble chips. Marble chips is actually the chemical composition of marble chips is calcium triazocarbonate 5, which is written as the CaCO3. So marble chips react with hydrochloric acid to give us the gas. So this is the setup of the reaction. So you have the marble chips in the conical flask, and then you have the hydrochloric acid being supplied to it. Then it reacts with it to give off this carbon dioxide gas, and that gas is collected over water. So you get your carbon dioxide, which is carbon 4 oxide. So this is the equation of the reaction. You have calcium chloride, water, and this is carbon 4 oxide gas, the product that we are looking for. But in the laboratory, there is a particular apparatus known as the CHEMISTY apparatus, which is used in the laboratory to obtain carbon 4 oxide anytime is needed. What happens there is that marble chips is mixed with hydrochloric acid, and the gas will be obtained, carbon 4 oxide, as the byproduct. So this apparatus is known as CHEMISTY apparatus. Now let's look at industrially. Carbon 4 oxide is obtained as a byproduct of fermentation. Fermentation is a biochemical reaction in which food substances, for example, locally where they make pap, that is ogi, that is locally called ogi. When ogi is being processed, you see, if you go to the place they process it, they will ferment corn, that's maize. What they do, they'll put it in an airtight container in the absence of air. These substances will decompose. So if you notice, if you go to those areas, you see a lot of gases being evolved from that substances. So in the industry, that gases that are being evolved are being collected and stored. So carbon 4 oxide is obtained in that process. It's not actually what is being is not actually what is being looked for, but as a byproduct, that byproduct will be used or will be collected, which is carbon 4 oxide, and used industrially. Then also, carbon 4 oxide is prepared when limestone. Now, limestone is also have the same chemical composition as marble chip, CaCO3, that's calcium triazocarbonate 5. So limestone, when limestone is heated to make quicklime, so this is limestone, CaCO3. When it is heated, you have quicklime, calcium oxide, and then you have carbon 4 oxide as the byproduct. So that carbon 4 oxide is collected. So industrially, that's how this carbon 4 oxide is obtained. Next, let's look at the physical properties of carbon 4 oxide. Carbon 4 oxide is a colorless and odorless gas with sharp, refreshing taste. You will still see the uses of each of these properties of carbon 4 oxide. It is about 1.5 times denser than air. It is slightly soluble in water. Carbon 4 oxide changes damp blue litmus paper pink. Now, remember when we were talking about this, we were talking about acid base, and so we said that acid turn blue litmus red. Now, carbon 4 oxide is an acid oxide. It's an acidic oxide because when you dissolve it in water, it will form triazocarbonate 4 acid. So that's why the blue color, that dampness is water. So that water reacts with the carbon 4 oxide, to give us triazocarbonate 4 acid, which turns that blue litmus paper pink. I know pink is close to red, and triazocarbonate 4 acid is a weak acid. That's why the color is pink, which is also close to red. So carbon 4 oxide changes that blue litmus paper pink. I hope we understand that. Then it does not support combustion. That means it does not support burning. So we'll soon see the uses of each of these properties. Next, let's look at the chemical properties of carbon 4 oxide. Carbon 4 oxide dissolved in water to leach Charles carbonate 4 acid, which is a weak basic acid. I said something like that just now. So that dampness in that litmus paper is what reacts with the water. That's what makes the litmus paper damp is water. So it reacts with dissolving water to give you that. Please pardon this equation is somewhat. Just a moment, please. So it's actually water plus carbon 4 oxide. Please pardon me, kind of mix up somewhere. So good. So we have carbon water reacting with carbon 4 oxide to give us the Charles carbonate 4 acid. Hope you understand that. So that's what turns the blue litmus pink. I know that the property of acid that they turn blue litmus red. So pink is close to red. Now that's one property. They dissolve in water to yield Charles carbonate 4 acid, which is a weak basic acid. Then number 2, carbon 4 oxide when passed over red hot coke. Use coke, please. When passed over red hot coke, it will reduce to carbon 2 oxide. So when you pass carbon 4 oxide over red hot coke, it will reduce to carbon 2 oxide. So you see that, you know, coke is one of the allotropic form of carbon. So when carbon 4 oxide is passed through coke, it will give you us carbon 2 oxide. That's the equation of the reaction. Next, it reacts with alkalis. The alkalis are substances which have the OH group that are soluble in water. It reacts with alkalis to form Charles carbonate 5. So look at this example. We have carbon 4 oxide reacting with sodium hydroxide to give us sodium Charles carbonate 5. Charles carbonate 4. So this is sodium Charles carbonate 4, a Charles carbonate, and then water. Then another alkaline, which is CaOH, calcium hydroxide, react with carbon 4 oxide to give us calcium Charles carbonate 4 and water. So all Charles carbonates, all alkalis react with carbon 4 oxide to give us Charles carbonate 4. Now, in excess, when CO2 is excess, the Charles carbonate 4 is converted to hydrogen Charles carbonate 4. Look at it. So the product from here reacts with more of carbon 4 oxide to give us sodium hydrogen Charles carbonate 5, and excess from calcium excess CO2 will react with calcium Charles carbonate 4 and water to give us calcium hydrogen Charles carbonate 4. Hope we are getting this. So when carbon 4 oxide is in limited supply, you have the Charles carbonate 4. But when excess of carbon 4 oxide is used, so those Charles carbonate 4 are converted to hydrogen Charles carbonate 4. So next thing we are looking at is the test for CO2. Now, let's go back to this equation. This reaction between calcium, carbon 4 oxide and calcium hydroxide is a very important reaction which helps to show the presence of carbon 4 oxide. Now look at it, carbon dioxide, which is carbon 4 oxide, CO2, turns lime water cloudy. Lime water is calcium hydroxide. So when you react them, you see calcium hydroxide, calcium, carbon 4 oxide plus calcium hydroxide, lime water will give you calcium carbonate, calcium Charles carbonate, and water. Now, did you see the product? So now calcium Charles carbonate is carbonate 4 is insoluble in water. That's why it will be cloudy. That is kind of a precipitated form. So it will be cloudy. But if you bubble excess of carbon dioxide, that means if you add more of carbon dioxide, it will give you this product. It will give you this product, calcium hydrogen triazole 4, which is soluble in water. So the solution which was cloudy before becomes clear. So at first, when you bubble the gas, it will form a cloudy solution. Then excess of it will now form a clear solution. That will tell you the presence of carbon dioxide. So let's look at the uses of carbon dioxide. Remember when we were talking about the properties of carbon dioxide? Said number one, that carbon dioxide, we said that carbon dioxide does not support combustion. So that's why carbon dioxide is used in fire extinguishers to put off lights. To put off fire. So when there's fire burning in an area, fire extinguishers are used to put off that. So most fire extinguishers contain carbon dioxide. Then the other property we talked about when we were talking about the physical properties of carbon dioxide, that they are colourless, odourless with refreshing taste. So because of that refreshing taste, they are used in soft drinks, like the soft drink we have Coca-Cola products, even in bottled waters and the Pepsis and 7-Up. Those drinks, they contain carbon dioxide. So when you open that gas that makes that pop sound, because the gas is put under high pressure into those drinks. So they help to give the drink a refreshing smell. So when you open it, you hear that pop sound. That is because of the property of carbon dioxide, which is refreshing taste of carbon dioxide. Then carbon dioxide is also used in is a product that makes dough to rise. When baking, they use baking powder. So when that baking powder reacts with the acidic content of the mixture, it produces carbon dioxide. That carbon dioxide is what makes the dough to rise. So these are the uses of carbon dioxide. So next thing we are looking at carbon oxide, CO. Now carbon oxide is produced by the incomplete combustion, that is of carbon or carbon containing substance, meaning that carbon oxide is produced when there is insufficient supply of oxygen or air. So you have any carbon-containing substance will produce carbon dioxide in limited supply of air. Now, carbon dioxide is found in traces as impurity in the atmosphere because it is released into the atmosphere from combustion of fuels in car exhaust, industries, and even homes. For example, the fuel that we use is made up of octane. So when octane burns in limited supply of air, you have carbon dioxide and water as the byproduct. So most times when there's combustion of fuel in cars and in the industry, carbon dioxide is produced. But there's something about carbon dioxide, it's a poisonous gas because it's combined with the hemoglobin of the blood. Now, hemoglobin is the oxygen carrying cell, or oxygen carrying cell of the blood. So the red blood cell is made up of hemoglobin, which helps to transport oxygen all around the blood. But when carbon dioxide is inhaled into the body of a person, that carbon dioxide will form a stable compound with hemoglobin. And so, because that stable compound is formed, it will prevent the carriage of blood all over the body, and so suffocation will set in. The person will suffocate from inside. That's why carbon dioxide is poisonous. I'm sure you've heard of this story where a family of 4 were killed because they put in their generators set into their sitting room while they slept. Or by the time it was morning, they were all found dead. That's because instead of oxygen, they were breathing in carbon monoxide, which is carbon oxide, and so oxygen could not be transported all over the body. So oxygen is required for life to be sustained. So because of the absence of oxygen, they were suffocated and they were all found dead. So that's why carbon dioxide is poisonous, because it stops the hemoglobin of the red blood cell from transporting oxygen to every other part of the body. Now look at how carbon dioxide are formed. From cars left running in an attached garage. So from cars, when there is incomplete combustion in them, you see carbon dioxide will go from generators, from corroded or disconnected water heater vents, portable kerosene or gas heaters. That the effectiveness is not so good. Then you have use of broken vent pipes, improper installed kitchen rank or vents, operating a grill indoors or in a gas. So because there is no sufficient air, so the gas that will be produced is carbon dioxide. If it was outside in an outdoor, there will be sufficient oxygen for carbon dioxide to be produced. Then burning of gas or wood burning fireplace will also, because there is insufficient oxygen in that particular place. So these are where carbon dioxide are produced, and we said they are poisonous. So methods for preparing carbon dioxide. Carbon dioxide is prepared by passing carbon dioxide over hot coke. Look at it. So this is the laboratory setup of that reaction. Now, concentrated sodium hydroxide is used to avoid the carbon dioxide being sucked back, and to convert, to remove the carbon. Look at the product. Some of the carbon dioxide will still be present in the reaction. So to remove it, concentrated sodium hydroxide will be used to remove the carbon dioxide so that is still present. So you now have your carbon dioxide as your product, and it's collected over water. Next thing we have, you can also prepare carbon dioxide by dehydrating formic acid. Formic acid is methanoic acid or oxalic acid, which is ethane dioic acid, using concentrated tetraoxosulfacic acid. Now, when we say dehydrating means removal of water molecule. So when water molecule is removed from formic acid or oxalic acid, you have your carbon monoxide, which is carbon dioxide. So look at here, you have potassium hydroxide solution. That potassium hydroxide is to remove carbon dioxide that is formed during the process of using oxalic acid as the substance that's being dehydrated. So to remove that carbon dioxide, you use potassium hydroxide to remove it, then you get your carbon dioxide as the product. Physical properties of carbon dioxide. Carbon dioxide is a poisonous gas, like I explained just now, which is colorless and odorless. That's the risk of carbon dioxide. It is odorless and colorless, so its presence in the atmosphere is difficult to be detected. So that's why it is very important, care must be taken when carbon dioxide is being used. For example, when we're talking about the laboratory preparation of carbon dioxide, these procedures, including the one using hot coke, these procedures are done in a few cupboards because of the poisonous nature of carbon dioxide. So to prevent poisoning from carbon monoxide, there is need for doing this procedure in a few cupboards. So carbon dioxide is poisonous. It is slightly less dense than air, and it is insoluble in water. Then CO2, carbon dioxide, is neutral to litmus paper. So these are the physical properties of carbon dioxide. Now let's look at the chemical property. Carbon dioxide burns in air to produce carbon dioxide. So when it burns in air, carbon dioxide will now be produced. Then carbon dioxide reduces metallic oxide to metals, and it's oxidized to carbon dioxide. Now, and it is itself oxidized to carbon dioxide. Now, this particular chemical property of carbon dioxide is useful. It's a useful property which is used industrially. You will soon see that when we go to the uses of carbon dioxide. So it reacts with metallic oxide. For example, this is iron 2 oxides, yes, iron 2 oxide react with carbon monoxide to give us the metallic, that is to give us the metal ion, and then you have carbon 4 oxide. Then this is carbon 2 oxide. Sorry, this is carbon 3 oxide. Yes, carbon 3, iron 3 oxide reacts with carbon 2 oxide to give you iron and carbon 4 oxide. Then with carbon 2 oxide, you have it reacts with carbon monoxide, that's carbon 2 oxide to give you copper and carbon 4 oxide. So this is another property of carbon 2 oxide. Then another property of carbon 2 oxide is that when it's added to chlorine in sunlight, that sunlight acts as a catalyst. Carbonyl chloride or phosphogen, which is COCl2, is produced. COCl2, which is phosphogen, is used in the manufacture of plastic and pesticides of industrial importance. So carbon 2 oxide reacts with chlorine gas to give us phosphogen, which is carbonyl chloride. These are the chemical properties of carbon 4 oxide. So let's look at uses of carbon 4 oxide. Just now we mentioned that this property of carbon 4 oxide reducing metallic oxide is useful. So it's used in the extraction of metals from their ore. Now metals, they are gotten naturally in their mixture of other substances. So get the metallic element itself, to get the metal itself, carbon 4 oxide is used to extract them, especially iron and copper. So oxide, most of them, you use carbon 2 oxide to extract them. Then usually carbon 4 oxide is found as in a mixture of fuel. For example, when we were talking last, we talked about producer gas, which is a mixture of nitrogen and carbon 2 oxide, while water gas is a mixture of hydrogen and carbon 2 oxide. So these substances are used as fuel industrially and even sometimes domestically. So this is where we are ending the class for today. So the note has been sent to you on the school website, and it's the week 8 note on the school website, and then we have other references: New School Chemistry by Babio and Exam Focus Chemistry by Ohia. Please try as much as possible to copy the notes and do the assignment, and most importantly, ask questions. I'm waiting for your questions, and I will get back to you once I get your question. Thank you very much for listening. I hope you learned a lot. Keep staying safe, and God bless you. I am Miss Adana Ogu. Stay blessed until I come your way next time. God bless you.